3, 2, 1, go!
Assalamu alaikum. Today I am going to show how to use the SDSM software. I'm sorry for any errors I might make during the explanation. So first of all, let us see how to download the software, its manual and the Hadley model data. So let me show you the links. So these are the links for the SDSM. This is the link for the SDSM software download and for the HADCM3 model. So you may type this link in your browser. You can copy this link or type this link in your browser, paste in. So this will open you the SDSM homepage. Earlier we used to download the data from this link on the website model data, but currently the website is facing a downtime, so I have used a different website for downloading the data, and that website link is the second link that I have provided here. So once you have opened the SDSM website, you can click on the software part. So you can download either the 5.2 version or the 4.2.9 version. I have in this tutorial I will use the 4.2.9 version, as there is a little bit variations with the 5.2 version and some users may find it difficult to use the 5.2 version. So we'll use the 4.2.9 version. So I have click on here to download the SDSM 4.2.9 version. Click here for the manual. If you click here, you will obtain a zip file, and for the direct executable exe file you can click here, but I would recommend to download this file instead. So I have downloaded the SDSM file, so double click on the setup file. Installing SDSM is a little bit tricky, as I'll show you. So I have so you'll see in this text there is no next or finish button, so you have to click the computer icon here, click continue. As I had already installed the SDSM, so it's showing the overwriting of the previous version, so I'll overwrite the previous version. So my SDSM 4.2.9 is set up is already. So let's open the SDSM. So where will it would be under SDSM 4.2, SDSM 4.2. So instead of opening 4.2, it opened up the 5.2 version. So let's open the SDSM 4.2 version. So this is the SDSM 4.2.9 version, and now for the SDSM data. We'll copy or write this link in our browser. So it will open as the Canadian climate data and scenarios web page, from where we can choose our model. So it's already opened here. We can see check our grid number. For example, for Kashmir or current location, we'll zoom in this page and check our grid. So it generally is a 21 cross 21 grid. So here you can check out the different data models that would be available in the zip file. So NCEP gives us data for 41 years, right from 1961 to 2001, and grid size is about 2.5 into 3.75 before normalization was implemented. So the other two give us 139 years of data from 1961 to 2010-99, that is for a period of 139 years, but its grid size is above 3. So there is a little bit difference variation in size, and the data is therefore resized. So normalization of the data is done, and resization is data is also done. So the ncp files are usually used for calibration of the model, and the h3 files are usually used for scenario generation. After this, we'll choose a grid. So we'll hover over this image and check which grid we have to use. So the grid I will be using, I'll first zoom in the image. The image, and now let's see for Kashmir it's 16 cross 16 grid. So we'll go down, choose 16, again choose 16 and click get data. So it will download a file for me. So I've already downloaded the file, but as you zoom and zoom out the image, the grid location will change, so be sure of that. So I'll close the Chrome window. So here I have, these are the files actually from the previous install or previous observation, so I'll delete them. So here I have the folder. Extract this folder and you will find 3 folders within the extracted folder, and within each folder you will get a set of 26 files. So now we'll head over to our SDSM. Now the basic thing that we have to know about SDSM is it takes files in .dat format. So we'll open our Excel file and convert it to .dat format. For that we'll copy the data from our Excel file, open Notepad, paste the data, save the data as observed.dat. So observed, I'll put it as 1985 to 2001. As I have data from 1985 to 2011, I will use observed 1985 to 2011 and save the file. So in the SDSM folder you will see that we have the DAT file now. So open SDSM, you will see the different options at the top, that is home, quality control, transform data, screen variables, calibrate model, weather generator, summary, statistics, frequency analyzer, scenario generator, compare result, time series analysis. Some of these are interrelated while rest are entirely different, and we may do our analysis without even using those options. So let us check these options one by one. So first is our quality control. So we can check our observed data for missing values, mean, minimum value, maximum value, etc. So let us test our observation file. So we will select the file, open the location of our file, observed 1985, open it, and then click the check file option. So it's showing us a total of 9720 values. So it shows us the minimum value, the maximum value, the mean of all the values, number of values in the file, we don't have any missing values here, so the missing values are 0. Number of values that are okay are 9720, that is we don't have any error. So also the maximum difference and other data here. So the missing value code, if we have a missing value anywhere, it will use minus 9999 for that value. So we may or may not use the quality control, but it is recommended that we used it before carrying out our data analysis. After the quality control is the transform data. So it helps us to transform data from into logarithm exponential forms, carrying the data, rooting the data, taking cube root of the data or fractions of the data. However, I have not used this option till now. Next is our screen variables. So this screen variables helps us in checking and filtering the data, that is which data we will use for analysis and which we will skip or strip out. So for this we have to first select the predictor file. So the predictor file is the observed data. So we'll click observed data, open the file. So we'll head over to the settings and choose our model. So here I'll use 360 GCM, since I have already converted my data as per 360 days as per the GCM model, but you may use the 366 days for your original data. So the data start date is my 1985, and the end date is 2011. By default you will see here 1961, and here you will see as 2001. So I have changed it. The event threshold we use 0 for temperature and 0.3 for rainfall. Missing data identifier is minus 999. So after that we have to select the directory in which our SDSM files are located. So we'll select C, users, Saqib, desktop, SDSM box, so NCP, and save it. Okay, then hit the back button. So here we have to get the predictor variables. For calibration and analysis or screening of variables, we use the NCP predictors. Double click here. So now we have set the path for the NCP folder. At the top we see the files within this folder, so we can use these files for analysis. However, there is one limitation, that at a time we can select only up to 12 variables maximum, that is we can tally only with 12 variables. About 12 it gives an error prompt 1 2 3 4 5 6 7 8 9 10 11 12 13. See, it gives its error that only display up to 12 predictors in correlation analysis. So we'll uncheck the last one and then hit the analyze option. Now we get the result window for the explained variances. So the analysis period is 1985 to 2011 at significance level 0.05. So it gives us a chart or a result table. Now the table, we will notice that the highest value of each variable for each month is red in color. For example, 0.091, 0.030, 0.048. For April, June, July, there is no value. So what is the meaning of these values? This shows that the particular variable, this is the how much effect a particular variable has on the data of a particular month. For April, June, July, and April, June, and July, there is no effect of these parameters, but for the rest there is a certain effect, and the highest effect, for example, in January is by the ZHAS parameter, which means surface divergence has the maximum effect for January. For Feb we have the maximum effect of surface meridian velocity, and so on for other. We may repeat it with the other 14 variables in this. So similarly, we can obtain a correlation analysis by using the correlation tab next to the analyze option. We will get a result window consisting of the correlation matrix, which shows us the correlation of the 12 selected variables with the observed data. Also, it shows us the partial R value and the P value for the data. This correlation data we will use for choosing the parameters for our further studies. So we'll choose the parameters which have the highest correlation. The meanings of these 13 you can check out from the manual, which I have told you how you will download. So after this analysis, we'll choose our variables for further study, but however these variables will be chosen only after we have done a correlation analysis with all the 26 variables present here. We can also obtain a scatter plot between the observed data and a predictor variable, but at a time only scatter plot can be obtained between only one predictor variable and the observed data. So we select the predictor file and the predictor and obtain a scatter plot. So you can see the scatter plot between the observed data and the mean sea level pressure. So we click the back. Now we have done our analysis or screening of variables. So after the screening variables, I have chosen the Tempas, MSL and P500 for my model calibration. So we'll select the predictor file is already selected. So this software is based on the multiple linear regression, where the observed data is the dependent variable, that is the observed 1985 2011 is the dependent variable, and Tempas, MSL pass and P500 that I have chosen from the predictor variable set are the independent variable. We can also get monthly, seasonal as well as annual results, but here we will do only monthly. For calibration, we will use 2/3 of the data, that is data from 1985 to 2001. So go to settings, select 1985 to 2001 and save the settings. So select the file path for the NCP, double click on the NCP and select NCP MSL pass, P500 and NCP Tempas. Now select the output file where the data results should be outputted. So we'll rename it to cal 85 to 2001. So click on the calibrate option. So we'll get the unconditional statistics in the new window. Also the unconditional statistics can be found in this par file. So what is in this par file, we'll check out using notepad. Open notepad and drag this par file onto the notepad. So these are the number of predictors, that is 3. These are this is the season code, whether 12 is for months as we have used monthly data. This shows us the year length. This one shows us the start of the year. This shows the number of days. This shows the start of the model fitting date. This shows the number of days used in model fitting. This shows us whether the model is conditional or not. True is for conditional, whereas false is for unconditional. This shows us the transformation. 1 means there is no transformation of the data. So this shows us the ensemble size. This shows us whether auto regression is enabled or not. So we haven't enabled it, therefore it's a false. This shows us the predictor file name, predictant file name, and these are the predictor file names. So we now have data in 12 rows and 6 columns. The 12 rows correspond to the 12 months of the year, And out of these 6 months, the first four are the intercepts and the parameters. That is, the first one shows the intercept, and the next three are the parameters corresponding to these three. And these two rows show the standard error and the r-square statistics. The last column denotes the root directory of the predictant file. That is the location of the predictant file. So let's close this window, open SDSM again. So we have calibrated our model. So after calibration, we'll head over to weather generation. So we'll select the parameter file that we have already generated and check the details. So this shows us that the number of predictors is 3, auto regression isn't done, process is unconditional, and SDSM version. Also it shows the start of the day, start of the synthesis, data analysis, and also the record length. So all these results we save in our .out file. So we will name it as 85-01 sim.out and select the, here we'll write the name of the predictor. So we'll do a synthesis. So we'll see that in the folder there are two files, sim and out. So this out file will open using our Excel. So we'll file, open, computer, desktop, SDSM. So here we'll choose all files and open the out file. So we'll see that there are 20 columns have been generated, and the length is about 6209 values that correspond to the values or number of days that we have already put here. So this gives us the simulated result from the SDSM model. So we can find the result by taking the average of the row so this row gives us an approximate of the entire row, and this we can compare with the original data. So we can see it's somewhere nearly near to the values of the original data. There is some variation. So after the weather generation, we'll use the summary statistics. Summary statistics we generally use to get the statistics from the modeled or the observed data. So we'll select the file. So it takes the .out file as input. So we'll say save statistics to, we can save the statistics to a text file. So we'll write it as stat 85-01. So we'll generate the statistics. Which one we have to? Median, count, extreme range. So we'll then analyze. So it shows us the mean, maximum, minimum, median, variance, sum, and count. So this will also be saved in SDSM folder within a text file. We can generate the same for our observed data and then compare the two files in the compare results tab by selecting the first file, text file, and then selecting other text file, and then using a bar or line comparison. After we have done the summary statistics, we can do the frequency analysis, although I haven't done it before, so I won't fiddle with it. So after that we'll go head over to scenario generation. That is our final method for generating the results for the rest of the year. So we'll first select the parameter file that we have already generated. So this one we'll select, and see the details. So you can see the details here. For scenario generation, we will use the Hadley Central model. So here we'll change the dates in the settings from 1985 to 2099. So we'll save it, select the Hadley model and select the output file. So we'll name it results 85 to 2099 and save. And now click the generate. Yes. So there's an issue, a file could not be found. So we'll again rename results, save, select parameter file, open here, we'll click this, so generate. So our scenario has been generated and we can check it in the results.out folder, but as such it would be open, so we'll again use our Excel to open the file. So we'll check open desktop SDSM. So our file was the results.out. So again we get 20 rows in 20 columns in each row, and to get the output we'll use the average from each row. So equal to average select the value, double click at the end, so it will generate the values for the years right from 1985 to 2099 or 1961 to 2099. So we'll, in order to check how many years it has generated, we'll use our calculator. So it's 5040 days divided by 360, so it's 139 years. So it has generated the results right from 1961 up to 2099. So these are the results for the daily temperature right from 1/1/1961 to 31st 12 19 31st 12 2099. So this is, so this is all about SDSM. Thank you.